Hey there, welcome back. This is 9-1 and we are talking about logarithms. In this video, we are going to go ahead and talk about how you evaluate logarithms without a calculator. All right, so it is possible to write exponential forms with powers on both sides with the same base. Then we can utilize the exponential property of equality. So maybe you're asking yourself, what is the exponential property of equality? Good question. Well, here it is. The exponential property of equality states that if you have an equation where you have the base of an exponential expression on both sides, that's the same. Okay, so left side is equal to the right side, the base is the same, well then their exponents have to be the same, okay? And intuitively this kind of makes sense, right? And an example of this would be something like this. If I said 7 to the power of x is equal to 7 to the power of 2, what is x? You would say it's 2, right? Because the left side is equal to the right side, the base is the same. So we're going to go ahead and use this, and we are going to follow these steps, and we are going to rewrite the logarithm in exponential form. Use a variable to represent the logarithm's value. Okay, then what we'll do is we'll rewrite both sides of the equation so they have the same base. That's important. And in this lesson, we're going to use a lot of our exponential properties to go ahead and kind of manipulate our expressions. 3, use the exponential property of equality and then solve for the variable if necessary. Okay, and it's very, very important that you understand the variable's value is the value of the logarithm, and we write our conclusion. Okay, so here is the first example, and we have log base 4 of 16. So what we're going to go ahead and do is we're going to set this equal to x. Just set it equal to x, make it an equation, and then we'll switch to exponential form, right? So that was step 1, and then here's step 2. I'm going to rewrite it as exponential form. So 4 to the power of x is equal to 16. Okay, step 1, step 2. Next, I'm going to go ahead and I need to have both sides be the same base. Okay, so this is 4 to the power of x is equal to 4 to the power of 2. Okay, thus, here's where we use our exponential property of equality. I'm going to say, okay, x is equal to 2, and then we'll solve for x. Well, in this case, we don't have to solve. This is a foundational example, so we can write our conclusion. Log base 4 of 16 is equal to 2. And there's your answer. Example 2. I'll go ahead and set my logarithmic expression equal to a variable. It can be x, it can be y. I'll use y just to mess with your guys' heads a little bit. You're welcome. You're welcome. Okay, so now I'll go ahead and rewrite this as an exponential expression. So 5 to the power of y is equal to 1 over the power of 125. Okay, now I have to make both sides the same base. So just look at both sides and say, okay, what base family could I utilize? And hopefully 5 comes to your mind. 5 to the power of y is equal to 1 over 5 to the power of 3. Now, I want this to be, want the 5 to be in the numerator. I want a base 5. So I'll use my negative exponent property. Okay, and thus we know, using the exponential property of equality, that y is equal to negative 3. Okay, so it's important, don't box y equals negative 3, right? You want to evaluate the logarithm. So we just used kind of a trick or a method to go ahead and evaluate this logarithm. So log base 5 of 1 over 125 is equal to negative 3. There you have it. That's it. Okay. Here are some practice problems. Please go ahead, pause the video. I want you to try these now. All right, so I'll assume that you have paused the video and tried these examples, and here are the solutions. Okay. Did you get them? Good job. Okay, so we'll go ahead and kind of ramp up our problems, make them a little bit more tricky. Again, you are welcome. So we have log base 36 of 6, and I'll set this equal to a variable. Next, I'll go ahead, I'll rewrite from logarithmic form to exponential form. So base 36 is 36 inputs and outputs switch. So 36 to the power of x is equal to 6. Okay, and now here, notice these are both family of 6s, right? Can't I rewrite 36? Whoa, can't I rewrite 36? Computer's freaking out on me. As 6 squared? Sure. Okay, so this is 6 to the power of 2x is equal to 6 to the power of 1. And thus, here I can use the exponential property of equality. Say it, exponential property of equality. This says if left side is equal to right side, bases are the same, then exponents are the same. 2x is equal to 1. Go ahead, divide both sides by 2. Le dos, x is equal to 1/2. Are we done? No, rewrite your answer. Do we have to? Yes, yes. Yes, you do. Log base 36 of 6 is equal to 1/2. Ta-da! All right, not too bad. Okay, let's look at another example. We have log base 1/7. Log base 1/7. Who even uses that? Nobody, except these problems. Log base 1/7 of 49. I'll set this equal to y. So we have 1/7 to the power of y is equal to 49. I'm smelling family of 7s. Actually, I can't really smell right now. I'm kind of under the weather. I'm sick a little bit. I promise not to get you sick. That's why you're watching this video. So we have 7 to the power of -1 to the power of y is equal to 7 squared. Okay, so now I'll go ahead and use power of a power property, which says 7 to the power of -y is equal to 7 squared. And then I'm going to go ahead and use exponential property of equality. -y is equal to 2. So if we divide both sides by -1, we know y is equal to -2. Which I always have to zoom out because I forget what the expression was. Log base 1/7 of 49 is equal to -2. All right, not so bad, right? Okay, so here is the next practice problems. Please go ahead and give these a try, pause the video, and I will assume you have paused. Here's the solutions. All right, so what I'm going to do, I'm going to go ahead and break apart. I'm going to split. I'll make this another video for the back half of the examples. All right, catch you next time.